Oh, hello. Thank you
Everybody.
guys for joining our shop. And yep, it's first technical difficulties. It was not easy to talk for me, but finally I'm unmuted. And let me check if the audio is fine or not.
Your audio sounds great. Thank you, Yuri. That's awesome. And Javi, I believe you already checked your audio and you're good to go from a presenting standpoint. Yep. All right, great. Give me 1 second. I'm going to share my screen and kick us off. Okay. All right. Welcome, everyone. It is Wednesday, November 13th, and you are in the Develop Decentralized Identity Solutions using Hyperledger Identus workshop. And we really want to thank our two presenters, Javier and Yuri, from IOHK. They are fantastic members of our community and contributors and maintainers of Linux Foundation Decentralized Trust projects, and we cannot thank them enough for doing this. Real quick, the Linux Foundation Decentralized Trust, it's the flagship organization within the LF for the development and deployment of decentralized systems and technologies. As with all meetings at the Linux Foundation, this is held in the Linux Foundation Antitrust Policy and the Linux Foundation Code of Conduct. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. And as far as the code of conduct goes, it can be summed up in one line. Be excellent to each other, be kind to each other, be nice to each other, be kind to our presenters. Just be cool. And we're all going to get along great. And we're going to learn a lot today thanks to this team, and we can't thank them enough. And lastly, open source only works with you. We need folks using the code. We need folks testing the code. We need folks contributing the code and becoming maintainers. There are lots of ways to get involved in the Linux Foundation projects. Get involved. You can sign up for a Linux Foundation account. Check out the code in GitHub. Search for open bugs. Check in GitHub for a good first ticket. That's usually a tag that a lot of projects put on good first tickets for someone who's just getting used to a new project. Read through the contribution guides for a project, find meeting info, working docs, and more on the wiki, and then use our communication channels, especially Discord. That's where all of our in-the-moment conversations are happening. I am going to share roughly 2 to 3 times an hour during the course of the workshop a set of links that includes very specific things to Identus, but also in general, the Linux Foundation Decentralized Trust Discord. Zoom in on small. Yeah, I'm almost done. And so with that, I would like to turn it over to Javier and Yuri and let them introduce themselves and take it away. Here we go.
Thank you. I'm already sharing the screen. I'm not sure if you guys can confirm that it's visible.
We can see it and you're visible.
Awesome. So we'll be presenting an interactive workshop around SDJWT, and we will be splitting this presentation in 2. The first part is going to be an introduction to identity inside Identus and a description of our components. And the second part of the session is going to be an interactive workshop with actual code and debugging session. And with that, I want to start by thanking the team for the effort in these past days to get this workshop completed and all the features that were included in that. And having that said, I'm going to land the keys to Yuri. So please go ahead. If at any point you need me to change the slide, just tell me.
Yep. Thank you, Javier. And I will ask you to keep an eye on the chat and if needed, interrupt me between the slides so we can cover particular questions that our community can ask for us. Okay?
Thank you, Yuri.
Yep. In my part, I am a software engineering team lead in IG, Identus project, and together with Javier and all other awesome engineers, we are working on the Identus platform, which is a really great project. And let me share a high-level overview of the Identus platform with the primary components and the features that we currently support. So, Javi, next slide.
Is it possible to increase the screen size on the window that you're sharing? We've got a couple of folks in chat who are having an issue seeing it.
Oh.
Yes, Arturo, this entire workshop will be streamed on YouTube. It'll be on the Linux Foundation Decentralized Trust YouTube. I'm going to share those links in 1 second.
Yes, probably it's better to share the link because next time we will play better with font size. Okay. Sorry for this.
That looks really good. You're in, Avi. I think we're looking good now.
Okay. So what is the Identus platform? First of all, it's an open source W3C distributed identity foundation and Hyperledger area standard-based SSI platform. The platform supports two DID methods. It's Prism DID and Pure DID. And currently we support 3 types of verifiable credentials. These are JWT-VC, Anon Creds version 1, and SD JWT credentials. Also, in order to properly manage all these credentials, we support JSON VC credential schema and bitstring revocation list registries in the Cloud Agent. And yep, the platform consists of the following components: Cloud Agent, Mediator, Prism node, and the number of SDKs. Currently, we have 3 SDKs in 3 languages: TypeScript, Swift, and Kotlin multi-platform, that allow us to enhance the developer experience and use a programming language convenient for the desired target platform. And we also have a Identus Apollo cryptography library that is shared among the components and implements particular cryptography suites in Kotlin multi-platform or Rust language. We have adapter for Rust. We also use DIDCOM v2 version protocol for peer-to-peer communication between the agent and SDKs and any other agents in the SSI ecosystem that supports DIDCOM v2. And we rely on Hyperledger areas application level protocols to cover the business cases between the issuer, holder, and the verifier. Among number of protocols that we support, there are well-known issue credentials, present proof, problem report, and revocation notifications. There are also trusted ping and DID exchange protocols to establish the connection between peers, and the number of these protocols are growing based on the community and our internal needs. Javi, next slide, please. Yep. This is a simplified high-level diagram of the components and the relation between components. So as you can see, ecosystem consists of main 3 parts, which are the core of the Identus platform. It's Edge Agent, Cloud Agent, and Mediator. For your information, Mediator is used as an active endpoint for the web and mobile applications that cannot expose the endpoint because of the target platform. You cannot expose a port using your mobile application. And you see Prism node and Cardano blockchain together with controller applications. These parts of the platform is related to the Cardano blockchain, which I will cover later. And as you see, Edge Agent can communicate with Cloud Agent directly because Cloud Agent is active service, but the Cloud Agent communicates with any Edge Agent using the Mediator. So each mobile and web application is able to pick up the messages from the Mediator service. Next slide, please. Okay. Everything was started around 6 years ago with the verifiable credentials and the Prism DID method, which was developed by cryptographer and engineers in the IAG company. And currently it's W3C compliant DID method that stores public data using the Cardano blockchain. So we store session method, public keys, and service endpoints, probably like any other DID methods that use the blockchain. And we also support 2 types of cryptography suites. It's SECP 25619 and AD 25519 keys. This PRISM method allows you to control your identity and communicate with other SSI peers like issuer, holder, and verifiers. So it's a well-known PRISM that is resided in the Cardano blockchain. And next slide. Yeah, and the Identus node or PRISM node is the microservice that contains the implementation of the PRISM method. So in short, it's a microservice that implements DPRISM specification, exposes the gRPC endpoint, and allows you to manage the PRISM Git lifecycle. So it allows you to submit, create, update, resolve, and deactivate operations, which are transformed to the event stream operations, added to the transactions, and published publicly on the Cardano blockchain. It's written in Scala and was designed to be used by the enterprise clients from the very beginning. So it supports batching of the operations, and it enhances the scalability and significantly reduces the transaction fees. So if you build in solution for organization, it's really convenient to use PRISM node. It will save some money for you. Probably it's not compared to the cost of infrastructure, but anyway, it's pretty good. And unfortunately, this repository is not open sourced, but we are working on this, and we have a commitment to open source this repository in 2024 year. Next slide. Yep. Identus Cloud Agent. It's a classic SSI cloud agent microservice implemented in Scala. It supports the methods that I described previously. It's a PRISM DIT and pure DIT. We heavily use pure DIT for DITCOM2 communication. Cloud Agent exposes two endpoints, one REST API endpoints for the HTTP client that we have in TypeScript, Kotlin, and TypeScript and Kotlin. And we also expose the DITCOM v2 endpoint for peer-to-peer communication over DITCOM protocol. Cloud Agent contains the implementation of the Hyperledger Areas protocols to fulfill the SSI use cases, and it also supports multi-tenancy, which was a very important feature around 1 year ago when we aimed to use Cloud Agent in organizations. So multi-tenancy provides the logical isolation of your digital wallets from each other and allows you to horizontally scale Cloud Agent and support pretty huge amount of active users that keep the digital wallets as a custodial solution. Additionally, the Cloud Agent can be configured to use key clock for identity and access management. We also able to integrate with Kafka for message streaming and scalability. And for advanced use cases, we also have a pluggable secured store, where we use HashiCorp Vault. As a good option, we also are integrated with observability stack like Loki, Prometheus, and Grafana. And we also have Helm charts and internal Kubernetes cluster, which is pretty good, but probably it's too complex for community. So we are working currently on a simplification of the infrastructure in order to make it adaptable for all our users. Next slide, Javi. Yep. Identus Mediator is very good, and I'd say very good because I'm a member of Identus team. It's an awesome mediator implemented in Scala. So it's asynchronous out of the box. It uses MongoDB as a data store and implements DITCOM v2 protocols that allows cloud and edge agent to communicate with each other. Currently, Identus Mediator supports HTTP and WebSocket protocols to send and receive DITCOM messages. WebSockets were added recently, and this improves dev experience by adding particular complexity. But using WebSocket, you can stream the DITCOM messages between the peers in an extremely efficient way. And as this microservice is stateless and uses MongoDB, it's horizontally scalable out of the box. So if you need to keep a huge load of the messages over DITCOM between your peers, this Identus Mediator is a component that you are looking for. And it can be used not only within the Identus platform. If you use DITCOM v2 protocol in your applications, you can use Identus Mediator like a standalone service for your personal purposes. Next slide. Yep. And probably the most interesting part of our platform is 3 different SDKs, not different because we have functionality parity between these SDKs, but 2 years ago we made the decision to switch from Kotlin multi-platform and support Swift and TypeScript native languages to improve the dev experience and allow any engineer and developer to use convenient language for your target platform. Using these SDKs, you can build web applications, mobile applications for Android and iOS, and this SDKs contains implementation for all capabilities that I described before. It's DITCOM v2 communication, verification of the verifiable credentials, communication with the cloud agent to use it like VDR for credential schema and revocation list, and all other use cases that are required in the SSI ecosystem between the issuer, holder, and the verifier. Yep. Probably that's it regarding SDKs. And the final slide, Javi, please. Yes. Overall, we have around 25 repositories, and I would say that around 10 or 15 are currently open sourced under the Hyperledger. We're still working on making as much as possible repositories open sourced, like open sourcing help chart and create kind of repository for infrastructure and the VDR. These repositories are not listed here, but in the scope of this workshop, we cannot cover all repositories. That's why I provided the links and the name with the purpose of these 8 repositories. So first one is Identus, is the entry point repository. You can navigate to all other repositories from README file. You can join Discord channel. You can look our GitHub project and discussions and actively participate in everything that is going on. Together with us, we can work on a roadmap and define the priorities and do whatever we want to make Identus platform successful. Identus Docs is a Docusaurus project where we keep all the documentation about Identus platform, references to the SDK and documentations, tutorials, main documentations for microservices, everything that you need to run Identus platform, and even use cases with examples that allows you to get up to speed with your particular solution. Identus Apollo is a Kotlin repository, which is a cryptography library that is used in all other components. So we use it in a mediator, cloud agent, and SDKs just to have a shared and same cryptography suits. Identus Cloud Agent and mediators. Nothing to say, it's just a Scala repositories with microservices and Docker images that we publish. And there are 3 SDKs repositories, TypeScript, Swift, and Kotlin, that are also provided here. Thank you for your attention, guys, and I'm ready to answer your questions if there are any, together with Javier. Javi?
Yeah, I think we can take, I'm not sure if the first round of questions, I've tried to answer most of them on the Zoom meeting.
That's awesome.
But I guess that we can answer the rest at the end of the call. But the most important ones I try to. That's why I was so slow sometimes on clicking the next button. So thank you, Yuri.
It's okay.
I will start then the interactive session.
Thank you, Yuri, and thank you to John Bauer for jumping in on all the questions. There are 2 questions, though, before we move on. I missed the first few slides. What VC type is the project using? I see SDJ on the roadmap. What's supported today?
So it's JWT on first side. Then we are also supporting Anoncreds V1 and also SDJWT. So the 3 credentials that are spread out there.
Yes. And in our roadmap, we have a ticket to support Open Badges 3.0 specification, which will force us to support JSON LD credential type as well. So I expect that in a couple of months, we will support additional types of credentials.
And I've got, John just answered the next question. What is the most important difference of Identus from Aries and Indy-based structures?
Yuri, do you mind if I answer that?
Yep. Go ahead, and I will add.
So, yeah, from the protocol perspective, we are using Bitcoin V2 protocol. So we are like literally a little bit more modern or updated than them. And we also provide mobile SDKs that, as far as I know, are not provided in Aries or Indy. Plus the fact that we are working or writing to Cardano blockchain.
And I think, thank you for that, Avi. I think with this last question, we can move on from Kirti. Can you give an example?
Guys,
go ahead.
A few comments. Yes, originally Identus was designed to be used by enterprise. So we also have options for HashiCorp Vault, Kafka, and Keycloak components that enforces particular enterprise capability like identity and access management. We also build OIDC, VCI, and VP extensions in the Identus platform, and we are aiming to be really scalable for custodial solution and very convenient for non-custodial solution in our SDKs. And probably that's the main differentiator. Everything else is, like how you told, it's a difference in the DITCOM V2 version, and we also rely on the same protocols. And thank you, Hyperledger Aries, for these great protocols.
And I think with one more, I think we answered the Kafka question with one more question. So what region is the current implementation aligned to and supports? EU, Canada, other? After this question, Yuri and Avi, if we can move on. But thank you, Keith, for the question. So what region is the current implementation aligned to and supports?
I'm not sure what this is really asking. What region? What does that mean exactly? If we are speaking about regulatory frameworks like eIDAS 2.0, we are currently not working on that, but there is already a couple of tasks in GitHub project where we are intending to bring OIDC protocol, which we partially support today. And OIDC protocol is the main way that eIDAS 2.0 uses to exchange information. So hope that answers. I do not know the Canada framework, if it exists. I have no idea. I'm sorry for that.
Okay, can you explain the use case in enterprise with how components agent will interact? Okay, can you go back to the slide with a high-level overview, Javi? Yes, this one. So Cloud Agent by default uses Postgres database to store the information about your digital wallet. Yep, but it's unsecure to store some seeds, public keys, private keys, and other sensitive information in Postgres in plain text. That's why it's possible to use HashiCorp Vault and use enterprise capabilities like encryption, special algorithm to unseal the vault, and even use a public cloud solution that will securely store your data in the cloud. It fits to custodial solution. And regarding Kafka, previously we had a state in the agent that wouldn't allow us to scale it horizontally. After major refactoring, we introduced the Kafka like a message queue and removed almost all state from the Cloud Agent. So the communication and the state management for DITCOM messages is happening through the Kafka, which is horizontally scalable out of the box. That's why Cloud Agent also can be scalable out of the box. And yep, I forgot about observability tools like Grafana, Loki, and Prometheus. We collect a number of metrics and able to store the logs in a centralized way. And finally, Keycloak. We use Keycloak as an option for Cloud Agent. And in Keycloak, you can configure, it's kind of a bridge between Web 2 and Web 3 applications. You can configure your proxy to Google, GitHub, or any other OIDC provider. We can configure, for instance, a token exchange, and you can use your GitHub token to access your digital wallet in the Cloud Agent. We also tried this approach. And by the way, we have a sandbox that you can use and try to see how does it work. And also for major organization, it's important capability to be able to integrate with existing IAM system to configure the digital wallets. For this purpose, we use the Keycloak. That's it.
Cool, thank you. I think we can close this first round on how tired are we? That's the first topic. Like the next session is going to be around 1 hour, or at least 45 minutes of coding and like jumping dirty into like real example. So how do
you guys are doing great. Let's keep going.
Okay, perfect. So I am going to stop sharing the screen in the current user. I have another laptop here where I'm going to, well, actually I leave the screen share on both sides. So let's get started. Okay, so the first thing that we are going to need to do is access the repository, and probably if somebody from the team can share, well, actually I do have access. So this is the link to the repository, and the way to start the workshop is extremely simple. Here I'm going to try and explain and introduce us to the workshop and explain like really quickly what the workshop is going to be about and what you can expect from it. So in this workshop, we are going to be building a story between Alice, a doctor, and a pharmacy, where they are going to be using self-sovereign credentials, in this case with SDJWT, to exchange some information and get Alice a prescription from a medicine that Alice needs. And then the doctor and the pharmacy need to be able to verify that Alice is really who she claims to be in order to give her the prescription or the medical prescription. So yeah. Also technically, as Yuri has introduced, we are using DITCOM v2 protocols. And as you know, some of the protocols include connecting 1 or 2 parties through DITCOM. there is something that over the time we thought that we could save one step from this connection. And yeah, we are basically using connectionless presentation and connectionless issuance. What that means is that you do not need to pre-establish a connection with the agent in order to start the credential exchange or the verification exchange. Then there are 3 components that are going to be involved. Well, actually 4, but 3 or 4 components that are going to be involved in this session. One is going to be the cloud agent, which Yuri already introduced. Well, actually all of them have been introduced. Mediator, the TypeScript SDK, and also the Prism node, which is not going to write for this demo the things on chain, but still it is applicable. Then for those that are in the session that you guys want to run the interactive way, I recommend you to make sure that your Docker is updated and that your Node.js version is around 20.x or higher. And then the only thing that you need is to clone the repository, change the folder to the folder where you basically see this README file. And then we are going to run npmi and npm run dev. And that's basically what I am going to do now. I am already in the folder. This is the same README that we were checking before. Awesome. This was extremely fast, probably because I already had it installed. And then the next thing that the demo is suggesting is to open localhost 3000, and that's what I'm going to try and do right now. Now, again, the workshop is going to be about Alice sharing some credentials with a doctor and then going to a pharmacy to get her medical prescription. Then what are the things that you need to run this workshop and make sure everything runs? The first, if you are running Mac, you need to make sure that you go to your Docker settings, resources, and click network and enable host networking. Then second, if in local you are running already services for whatever you are developing, you must know that the following ports need to be available and not consumed in order for the demo to work. And then the third thing, we are going to make it easier for everyone in this room by sharing the GitHub, the Docker, the Docker registry GitHub token, which is something that if you run the demo tomorrow or at any point in time, you will need to configure that. I fully recommend just reading the tutorial that is on the GitHub website. And then what you need is you will generate a token on your side, and this is the command that you will paste in your console to log in with that token and this username. That's a required step. And I'm going to please ask Alain if he can just send we have built a token for everyone in this room to be able to go through the demo without having to configure the GitHub token. But the token will expire in a couple of days, so it won't be available forever. Then having that said, it's very simple. We are just going to copy this in my machine. Also in the same folder where we were running this, we just run docker compose up. And we are going to wait a little bit for the first, for the agent to boot up. And I am going to wait for an SSH message or something like that. It's HTTPS, sorry, not SSH. Yes, this one. Okay. So the first thing, as I said, is that we are going to make this extremely interactive. So we are going to, on every step, we are going to be writing the code. So what I recommend is that you just read and follow the instructions in this file and concretely save the things as they are mentioned in here. Because that way we know that the workshop is, you are going to be able to run the workshop without any issues. So yeah, sorry. Yeah, that's the first part. I'm just getting a little bit annoyed because my mouse is moving from one screen to the other. but I guess that I need to live with that. So as we see, this is just importing. The SDK is already imported, and then there are three things that we need to configure in the environment. The first one is to create a Prism DID with ID to 5519 keys. We will do that by doing an API call to the agent. And then that DID is an unpublished DID until the issuer does not manually run the published DID. Then, as we said, for this example, we are not publishing the DIDs on chain, but the Prism the Identus node can be configured to write things on the Cardano testnet or the Cardano main. So again, what we are going to try and do here is make sure that we can run these API calls and we can actually see what is the response. So then remember, Yuri in the presentation talked about there is two ways of handling a Prism DID. One is the long form Prism DID, which is what you see now. The long form, for those that have a little bit more knowledge about DID methods, the long form Prism DID is like using DID key. So the public keys of the DID are bundled inside the DID. The difference between the long form Prism DID and the short form Prism DID is that as the name says, this one is very long because it contains the public keys and the short form doesn't have. And then in here, we are going to be able to see what is the short form DID and why is it like that. Right? So in order to get that resolved or know what are the keys, you would need a resolver for that. And then in this last API call, what we are using is the Prism DID that we created in the first step to create a credential schema for SDJWT. And it's not very important or relevant, but we are just using a specific schema, as you see, to get the patient ID, the patient name, patient family name, prescription ID, and date of issuance. And then we will be computing the verification request based on these attributes. So yeah, having that said, we want to make this extremely interactive. So I am going to be copying the code that is offered in every single step and pasting the code on screen so we can see, yeah, how interactive it is. This is just the register Prism DID API call. This is going to be the one where we get the long form Prism DID and we publish it. And the third one, as we spoke or we said already, is going to be the creation of the credential schema for SDJWT. There is really not much difference between a JWT and an SDJWT schema. Then in here, we could already start running the thing just to make sure that things are working and that we are not going to find any surprise. And we can see, as in the UI, we have the response from the credential schema. So yeah, this means we can basically continue with the workshop. What you've seen in here in the code is literally the same that you see on screen. So you guys can just listen to my explanation. You guys can wait and run it later, or you guys can run it with me. And if at any point in the workshop you need you need me to stop and ask anything important, the guys will probably notify me about the question, and that's it.
Javi,
So
can
yeah.
you a little bit zoom up the text? Yep, like make
This,
it
in the
like
website.
this. Yes, awesome.
Yep. Cool. So having that said, we are just going to jump to the next step. In the next step, I am going to talk about the same theory that you represented 10 minutes ago. So we are not going to repeat again. The only difference between the long form and the short form is the long form has the keys inside and the short form doesn't. If you see, the identifier of that DID is the same one. So every long form has a representation in its short form. Then having that said, when you publish a DID, you would publish that on chain. And then when a verifier requests you to create a proof for your credential, you would need to check internally if that credential was issued by the doctor. And then how would you do that? You would need a DID resolver. For the purpose of this demo, we have created an API called DID resolver, which in a normal production example would be replaced by a DID resolver, which would resolve things from the Cardano mainnet or the Cardano testnet. But the resolver shape is more or less the same. It's just the resolve method is going to look slightly different. Then not much, but it's just getting the response from the agent and building the DID document out of the response. And that's basically what this does. As we are being told, we are just going to copy this into our script and then continue with the presentation. Then in this step, every edge agent needs to connect to a mediator. What's the reason? So as you may know, the mobile devices or in a browser, you cannot create a port or a service that is running on a specific port. It's because of how networking works internally. So you need a mediator. The mediator is somehow like an email inbox where your messages get stored while your browser app is closed or your mobile app is turned off. So then what we are going to do here is establish, make an API request to that mediator in order for that mediator to tell me what is their mediator DID. And the response can be seen in here. And in this case, as you see, because this is a DIDCOM communication and a DIDCOM DID, it is using DID peers and not the Prism DIDs. Because the purpose of this DID is another one, just to establish a secure connection between two parties, in this case, between Alice and the doctor. So yeah, having that said, we need to copy every single step of the guide. And this is one of the last steps that we need in order to start our local agent. Then as we are told in this code, we can see how easy it is to instantiate the edge agent on TypeScript. What you see here is the different building blocks that we have, well, not all of them, but some of the building blocks that we use on Identus. Apollo is our cryptographic package. Castor is our DID-related building block. Pluto is our storage layer. And everything that you see here is built with foundationally by creating strong and robust protocols and interfaces. So it is very easy to extend in a future with new DID methods and these kind of things. Even if your DID method requires a different algorithm that is not supported, you can bring this algorithm by implementing your own interface on Pluto or on Apollo. And yeah, having that said, we can just continue building our script. Probably in here, you guys also want the script to be slightly bigger. So yeah, let's go to the top, copy the import dependencies that we need, and go back to the example. And the last step of this page is going to be asking us to do two things. The first one, to add the listener, which is empty in this step. And the second one is going to be starting the agent. So what is going to happen here and why do we need a listener? We need to create that listener because every single DIDCOM message that you receive through the mediator happens asynchronously. So you need to have a way to listen for incoming messages. And in the same way, we have other listeners to listen for new connections or to listen when a credential has been revoked. And in this case, exclusively speaking about JWT and not the SDJWT one. Then we have the script here in this way, and then by clicking next, what is going to happen literally is that this website has the same code that we have in here, and it is going to start the agent. So after this screen, we will have an agent that is already connected, and we are going to be able to start listening for messages. That's why in this next step, it's going to be a little bit slower because everything is starting up. And in the same way, you need to be able to start your agent in exactly the same way. What is going to happen here? So now Alice is in her doctor and she's asking the doctor for what? Well, she's not asking the doctor. The doctor thinks that she needs to have a medical prescription. So this doctor is going to establish a secure way to communicate with Alice. And then he's going to basically provide Alice with a credential offer. The credential offer is something that Alice will receive. And Alice will say, like, the doctor wants to issue you a medical prescription of this type, and this type. And then Alice will be responsible of accepting or rejecting this. And then first I'm going to just run the code in the browser and then copy the things into text. So the first thing that happens after you create a credential, a connectionless credential offer is that you get an invitation URL, which contains an out-of-band link. This out-of-band link contains the credential offer inside. And then what can we do? So after you receive this credential, this out-of-band link, what you need to do is you need to parse it with the SDK, and you need to accept that DITCOM invitation. Everything that you see here on TypeScript can run on all the mobile platforms. So it's pretty much the same. I just copied this one. Now I need to get the invitation URL and accept it. So by doing this, we will convert the invitation link into a credential offer that we should receive in our listener that we created earlier. So if we go to the listener that is empty right now, and we just update it by making sure that we are adding a console log when we receive an offer. In this step, if we run the code, we should already see that it's stopping in the right place. This is the creation of the schema. And now we have the DITCOM message. The DITCOM message that is of type issue credential, and inside the variant of offer credential contains a specific attachment that is either on encoded with JSON or any other format. And inside this message, we have the attachment, and the attachment contains the actual credential offer. So having that said, we can run again to the interactive way of displaying stuff. And now we are going to run the interactive way. So by processing, which is the same that we wrote previously, we get the credential offer, which tells Alice that she's going to be receiving a specific credential that will contain these fields, and she can either accept or reject this credential. Of course, keep in mind that we've tried to simplify things as much as possible. So you will see the holder, the verifier, and the issuer on the same screen, but it's just an example, right? So in order to then receive the credential and be able to listen to that credential, we will need to add another else condition in the listener that we created, this time listening for a DITCOM issue credential message. Then while we do that, we know already that this credential payload is going to be an SDGWT credential, so we are already storing this credential for later use. So let's copy this part of the code and run it again and see what happens. In this case, again, we are already everything that we showed is already being accepted. So in here, what is happening or what you see here is we are logging the credential offer and we are automatically accepting that credential offer, which is what you've seen in the UI that I will do by clicking accept. And then the last step is that you actually get the credential, which is securely stored in your Edge agent SDK. Cool. So this confirms that we have received a valid SDJWT credential, and you can see part of the disclosures around here. And not much more. It's just a classic JWT with the disclosures bundled at the end. Cool. So having that said, now we go back to the interactive way. So what happens when Alice accepts that she accepts the credential from the doctor is that she will receive the actual SDJWT credential. And just for the purpose of the demo, we decided to make all the fields disclosed by default. So not even the holder can see the values, but you can disclose and reveal the value. And this is actually really revealing the attribute. It's not just hidden in the UI. So this is the first step of the workshop. What has happened in this first stage is that Alice went to the doctor. The doctor prescribed her, or the doctor created an offer for Alice to tell her, look, I'm going to prescribe you whatever medicine. In this case, this prescription ID, and then Alice received that credential offer and decided to accept it. Then Alice goes away, goes home, and then tomorrow Alice goes to the pharmacy and will use the credential issued by this doctor to get her medication.
Thank you, Javi. I just wanted to ask, can you copy and paste the encoded SDJWT credentials to SDJWT IO site just to show the internal decoded part and confirm that it's interoperable?
Yeah, if you don't mind, I will leave that for the end. But
Okay.
yeah, for sure we'll do. So in this second step, it's again, Alice goes to the pharmacy and the pharmacy is the verifier. The pharmacy will then issue a verification request that Alice will either accept or reject. And then the pharmacy will be able to see if Alice really had issued a prescription to her wallet and that Alice is who she claims to be. And then this connectionless presentation flow is more or less the same, literally, than the other one. It's just that in the first connectionless flow, we got a credential offer. And in this second one, we are going to have a presentation request. But really, it is the same concept. As it is the same concept, if you scroll down, you will see another invitation link with another out-of-band message that is in the same way. So, and again, as you see in this step, which is parsing the link, it is exactly the same code that we ran in previous step. And this accept invitation is also the same step that we ran in previous step. Let's just copy the code to make sure that we are doing the right thing. So in this case, the presentation request, we should start sending it right after receiving the credential, because this is a demonstration. And right after creating this presentation request, we are going to be accepting this presentation request, and then the new message will pop up in our listener, which is what we see here. In the first step, we created the offer. In the second step, we are storing the credential and creating and accepting the DITCOM, accepting the out-of-band verification request. And the outcome of accepting it is that you will receive another event that contains a DITCOM request presentation. And this is already moving one step further. So by clicking this accept out of band request, we are going to be seeing the message. Let's see. Now, if we scroll down, this DITCOM request presentation that we've seen is shown to Alice in this way, in this horrible way, where Alice is being told that she needs to disclose a valid credential with a valid patient ID and a valid prescription ID. Then Alice has already a selector with the credentials that she got and the issuer that issued that credential. And then Alice can send the verification or the presentation, which is the part of the code that you see here. So what is happening is that we are getting the credential that we got in the previous step in here. We are actually sending that presentation using that credential. And then if we already selected the credential, we should be able to run an API call to verify the presentation submission that from the verifier. So this is the pharmacy that would run this verification. And we can see that the presentation is verified. Then I would say this is the whole flow, but I still want to make sure that everyone has the opportunity to run it and to just see how the code looks and so on. So in the last step, we are providing the full working code for those that want it. And yeah, let's just debug again and make sure that we understand every single step. Let me zoom out a little bit to add debuggers on the lines that I think we should stop. In here, we also want one in here, another one here, here. Cool. So again, let's review from the top what we added and how to actually run it on your local machine. We needed this short form DID resolver in order to get the keys of that short form prism DID. And this is important because when you receive that credential from Alice in the pharmacy will get that DID, will resolve the public keys of that DID, and then verify that the presentation was signed with the right keys and that the credential inside that presentation was issued by the right person. So this is very important to understand. Then in here, the first step or the first three steps would be to first register the prism DID, which is the long form prism DID. Second step would be publishing this DID on chain. And the third step would be to create the SDGWT credential schema, which is what we already see on screen. And let's continue from here. Then, as we said, when an edge agent, so when the website starts communicating, it needs to have a mediator. Why? Because when the browser session closes or the mobile app turns off, the mediator will be storing those messages for you. So whenever you come back the next day, you will receive the DITCOM messages that you were not able to receive while you didn't have connectivity. And the first step is just to configure the SDK to use a mediator, and that's what we are doing here. We are fetching the mediator from the API call, and we are creating the agent with what? We are creating the agent with our Apollo cryptographic package, with our store, which is in this case storing things in memory, and also using a hashed password, which even if it's in memory, it will be encrypting data. And then the last 2 or 3 steps that we see here is we are creating the extra resolver, which is that required step that we need in order to make sure that that credential was issued by the pharmacy. And then we are also going to have Castor, which is our building block for DIDs. And we are going to pass the cryptographic package and the extra resolvers. The last function is self-explanatory. It's the agent initialize function, and you need to basically pass the building blocks that you want. And if you access to the documentation, you will see that you can basically extend other building blocks. Like you could write Castor in your own way with your own specifications. You can write Pollux, which is our component responsible of handling credentials, to include other type of credentials that you need to support in your use case. Or in the same way, if your credentials are using an algorithm that is not supported by default by Identus, you can implement your own Apollo. And if you build a compliant class, you can basically use it in our agent. It really doesn't matter. So I think one of the things that we are like really trying to be good at is at being extendable and easy to adapt and integrate with. And this is something that we foundationally built the SDK in this way, so we could enable that. Having that said, we have the mediator and we have the agent started. Well, actually, no, not yet. The agent is now in here and we have the listener, which is not going to trigger yet. We want to stop in the agent start. Well, now the agent already started. And then as we said, as we did in the interactive demo, we are going to be requesting the credential offer, right? And then as soon as we get the out of band credential offer, we are going to accept that link. And this will move or create the credential offer in the listener. So that's what we are going to see now. We are going to accept this parsed credential. And now it already triggered internally that there is a new message of type credential offer. Then what we are seeing here is basically Alice is accepting that she actually wants this credential. And she's creating a request credential DITCOM message, which is its own protocol. So it is handling the request credential message, and it is sending that back to the agent. And again, from this step, we already know the next step is that Alice will receive the issued credential, which is in this next if condition. We need a little bit more time probably to receive the SDHWT credential, but we already got it. Then assuming that that credential is bundled, we have the compact SDHWT. Sorry, I'm not sure if I copied. No. Okay, I did now. So now let's go to the SDHWT website as Yuri was suggesting. And let's copy. Did I not do that wrong? Like the credential needs to be valid. If not, like nothing that we are showing in this presentation would make sense. Okay, that looks better. That looks better, but still a little bit weird to have. I think I know where my trouble is coming from. I just think my screen is zoomed out and yeah, it's a little bit weird. But yeah, as you see, we are using EDDSA's signature algorithm to sign this SDHWT credential with the ED25519 keys. Then everything that you see in here in the payload are just the encrypted fields that Alice did not want to disclose. And here we have the public key representation of that key. And here the disclosure, we can also see that there is some fields that are disclosed or are not disclosed. So basically we have full support for the selective disclosure of SDHWT credentials. And then, yeah, I guess that after covering that, we can just continue again with the presentation. So now we have the credential. Alice is going to go to the pharmacy. The pharmacist is going to create a presentation request, which is this API call. and it's going to ask Alice to share a credential with a patient ID and a prescription ID. And that's what's going to happen right now. As soon as we get this presentation ID, we are going to be accepting this invitation link, like in the UI that we've seen earlier, and then the DITCOM presentation request will appear in the listener. So this is the last step where basically Alice gets in her mobile phone or her browser application, she gets a notification that some pharmacist wants to prove a credential with a specific set of claims. And that's what we are going to do here. As you see, we are getting the request presentation message, and we are attaching the SDGWT credential that we got in one of the previous steps. And then last, we are sending this presentation through DITCOM protocol back to the agent. This last API call that you see in here is basically to prove that this whole workshop was a real example. We have not faked anything. This is a real thing. So by running this get API call to the presentation ID, we are going to verify and make sure that this credential, this presentation proof is valid and correctly signed and all that. Now verification is true. What does that mean? This means that the presentation was signed by Alice, the presentation contains a credential, and that it has been issued by the right issuer. And all that through SDGWT and the credential payloads. That's it. I was really hoping that we would need more time, but I guess that things went really smooth. Do you guys have any questions or?
Yes, if you have a question, please put it in chat. Thanks.
Again, the full code and the not just the full code, but everything that you've seen in this presentation is available in the workshop and in the TypeScript repository if you go to demos and Next.js SDGWT workshop, and you can follow the instructions on screen. Oof, I went coughing pretty bad. Okay, so yeah, having that said, is there any questions or? So to reply to some of the questions that I'm seeing on screen, sorry if I do not see all of them, but I just saw the most recent one. So right now we are not computing zero knowledge proof for SDGWT. As far as I know, until now, we are supporting selective disclosure and not zero knowledge proof. But with we are going to, so as we said, we support 3 different credential types. We support GWT, we support unencrypted v1, and we support SDGWT. In the case of unencrypted v1, we could do that with unencrypted. With unencrypted, you can choose which fields you want to disclose, and you can also confirm that they are over 18 or higher than 18. It is 100% supported in both, I guess. I'm going to try and scroll up, but Yuri, do you think that there is any question that we should answer publicly or?
Great presentation. I hope that guys were able to follow you, and me and Alan helped to answer to the questions in the chat. And overall, in the current workshop, we have a simplified use case, and if there is a real need to have more advanced use cases, we can consider to do this in the next workshop.
Yeah, we are likely going to be doing more workshops because on my own experience, building this has helped us a lot to understand this with different eyes. Plus, I think one of the things that we are missing as a community in Hyperledger Identus is that we didn't have enough examples. And concrete examples mean that it's not like so generic. It is, in this case, Alice goes to a doctor to do a very simple thing that we do many times in our lives. Go to a doctor to get a medical prescription. And then in a future world where we are all going to live in a trustless ecosystem and trustless world, Alice will go to the pharmacy, and then this pharmacist should be able to verify that she claims who she claims to be. And she doesn't need to trust that person anymore. But she will know that the presentation is cryptographically valid, that they can be for sure certain that this information is correct. Okay, anyone else that wants to maybe, I don't know, give their thoughts, or if you had any trouble running the demo or anything, we'll be happy to help.
Please put your question in chat so everybody can see it and our two presenters can capture it. I also just added for the last time probably in this call the links for this call. So we've got the live stream. There is a Identus YouTube playlist, which includes it's going to include this workshop, but also all the community meetings that team has. We've got links to GitHub, the workshop links that Javier and Yuri have been presenting in this demo that they just did is there as well. There's an Identus mailing list, an Identus Wiki. We have a community calendar of calls, as well as our Discord, which is where all the in-the-moment conversations happen. So by all means, check out those links. But please, if you have questions for these two great presenters, please let us know, or type it in chat so we can answer it.
Do you mind if I just present 2 additional minutes? I think
Yeah.
I want to present.
This is Yuri. This is your workshop. Yuri and Avi, this is your workshop.
Yeah, I don't know.
But I do have a question in the chat. After pharmacist gives the medicine, how is the prescription updated so that it cannot be reused? Can only the issuer update that? That's a question from Gavin.
That is an excellent question. Like, we did not really cover that, because this at the end is not a complete solution. It's just a workshop to make sure that we understand how issuing and verifying a presentation works, but we are not going so deep in that. But probably it is a very interesting question to have single-use presentations or stuff like that. Probably the pharmacy should store or keep a registry of the things that they have been issued, but if not, I don't know, it would need to be something a little bit more custom.
Yes, Javi is right. It depends on particular implementation, but in the SSI domain, it's really important to keep privacy of the peers, like holders, and follow some GDPR constraints and other policies. So that's why probably there are no areas protocols between the verifier and the issuer, because it's called like a call home pattern when you are checking a revocation list or have some communication between the verifier and the issuer parties. But if you are building something for pharmacy and you use a similar platform, the issuer and the verifier can use even same agent or different cloud agents, and it's possible to design the protocol between verifier and issuer when verifier will prove that there was a credential demonstrated by a particular holder, and this verifiable credential must be immediately revoked. So in this case, after using the verifiable credential in pharmacy, the verifier will be able to notify issuer to update their revocation registry. Something like that.
But actually, Yuri, I think Shailesh answered the thing very well. So, if you have or receive a presentation out of band invitation and you used it once, you will not be able to consume it twice. And also the invitation links get expired. So this would be a way to prevent Alice from abusing her medication and stuff like that, if that's what we were asking.
But it's more for the case when you have two pharmacies in a row and you use your VC present to one pharmacy, another pharmacy, and they both sell you drugs.
Yeah, that is correct. For this, we would need to have
It's
some
not
extra.
about expiration. You see, it's not about expiration.
Yes.
It's about misuse. And probably, yeah, another option is to use some smart contracts, but it's out of the scope of the current workshop.
Yes. Then on top of that, I want to also, like we have recently shifted from like, as you know, IO as a company is maintaining the team, fostering the Hyperledger Identus project. And over the time, we switched from a closed way of working to a more open and transparent way of working and more open source. So far, I would really recommend everyone to come and check our roadmap. Why I think this is important is because you can see the things that we are likely going to be working on in the next months. You can see the things that are in the backlog, which we are no longer going to pursue, but we are still very interested either on having some help from the community or on starting the discussions. So very important talks are happening here around, for example, how do we revoke an SDGWT credential? Because as some of you may know, there is no like a closed specification to revoke SDGWT credentials, right? So here we are starting to have the discussion around that. Then, as we also mentioned, that the way to interconnect with other like regulatory frameworks like the one in Europe would be to implement the complete suite of OIDC, which we are no longer going to be working on, but still it is here well documented and well described, so anyone in the community can pick that up. And also we are like we get extremely happy when we see contributions coming from the outside. It doesn't need to be a huge contribution. It can be maybe open an issue of something that you do not understand in the documentation of some struggle that you had, like that you also explain us and participate in the discussions that we are building is very valuable. Let me show you an example of what the discussions look like. So again, this is pretty recent, and yeah, this will grow hopefully over time. But one very good example is we were discussing internally if we want to do issuance capabilities to our SDKs. So we wrote a ticket. Then, as some of you may know, we are sitting every Tuesday in the afternoon, more or less at this hour, but on Tuesday, well, a little bit earlier. And we are sitting down and reviewing all these discussions that we have. Then for this concrete case, I created a poll to basically try to understand better from your perspective, not just ours, but from the community perspective, who would see benefit on us doing that. And then over the time, each one of us brought its 2 cents on this. And then as we agreed, we were going to close the voting. And then as it was voted and it was a successful vote, we are going to be prioritizing that as part of our roadmap. And in the same way, I recommend everyone to just bring open debate, create issues and stuff like that. A very good example from some of our peers is a new initiative from the Socials team, which have been with the community for a very long period of time. And they have been working on an initiative, which is to create a different password protected backup system than the one that we have now. Then from this discussion and some involvement with the actual team of Identus, their team contributed to a great, at least proposal, which is minimizing the backup size by using a different backup schema. So these are the type of things that we would greatly benefit from. And it is really helpful for seeing people from other projects come to Identus. And also, I am sure that our interface or protocol-based architecture is going to make integration easier for your project. So it doesn't really matter where you come from, that if you need an SSI platform, that you can connect different devices, not just web technologies, but you need for your project like native performance, meaning that you need to run Kotlin code directly on your mobile, or you need to run Swift directly on your device. I don't need that. I don't think that it is very clever to sacrifice all that and build a quick website application on top. And I say that being a website developer myself. But I don't think it makes sense. So we provide these native platforms. Everything that you've seen in this workshop is in the same way replicable to any of the SDKs that we have. And yeah, that's it, I guess.
All right. Are there any other questions? Please put them in chat before we close this workshop. And just a reminder, Sefa just asks, does Identus have a wallet like Aries, or will there be one?
Well, what you've seen in the workshop, like that website that I showed, is literally a web wallet for identity. It's not a crypto wallet on Cardano, it's an identity wallet. Like we already provide that naturally with any SDK that we use. But are we building a production-ready product that is a wallet for Identus? The answer is for now, no. But internally on I/O, we are exploring and allocating some amount of effort on trying to integrate with other internal tools. So it makes a lot more sense for us to integrate with Lace, which is already a robust wallet out there. But yeah, we are very interested on seeing other wallets implement identity. And we recommend, yeah, we open the doors to everyone in Cardano and other protocols to integrate.
And thanks again to Alan and John for asking questions in the chat. Oh, and also our two great presenters, Yuri and Javier, who were doing it while each other are presenting. Okay, does anyone else have a question for the Identus team before we close this workshop? I don't want to end it too soon. I have shared the link to Discord, the Identus mailing list, and the Identus community calendar. They have, correct me if I'm wrong, Yuri, weekly meetings as a community, as well as I've shared the GitHub and the links that were shared in the demo. All of this will be in the description on YouTube, as well as on the wiki page. And I'm going to ask our presenters if they could send me the deck slides so we can PDF them and put them up on the wiki as well.
Yes.
You guys are the best. Thank you so much. I think that's it. Listen, thank you everyone for joining us today for the Developing Decentralized Identity Solutions using Hyperledger Identus. We cannot thank you all enough for joining us. And most importantly, thank you, Yuri and Javier, and the team at Identus who put together this great workshop and gave such a great presentation. We're answering the questions. Please, if you have more questions, if you want to find out more, check out some of the links I've already shared. This entire video is on YouTube right now. We've been live streaming it the entire time. And I'm going to put these links into both the YouTube description as well as the wiki page. And with that, I'm going to thank everybody and shut this off. Have a great day, everyone. Thank you, Yuri, and thank you, Javier.
Thank you, guys.
Everyone.
Great job. Bye, y'all.